Hello students, this is the second video of this chapter, volume and surface area of the solids. In this video, I am going to discuss the volume of the solids, that is three-dimensional figures, right? Now at first, think what is volume? Try to think what is volume? What is the volume of this cuboid? What is the volume of this bottle? The volume means the space, the amount of space that a three-dimensional object takes in. Okay. This is a cuboid, right? Made of cardboard, and there should be a certain space in the cuboid box, right? There should be a certain space in the cylindrical bottle. That amount of space is called its volume, this bottle's volume. The amount of space occupied by this box is called the volume of this cuboid. Okay. Now let's learn how to calculate this volume. Here, this is a picture of cuboid and this is a picture of cube. Okay. Suppose this length is 4 units. This height is 3 units. And this is the breadth here of the box, right? Suppose the breadth is 6 units. I just said that the volume of a solid means the amount of space occupied by that three-dimensional object, right? Here, in other words, you can say, if I have to find out the volume of this cuboid, then I have to find out how many cubes of unit length, unit breadth and unit height can be accommodated here at maximum. Maximum how many cubes of unit length, unit breadth and unit height can be accommodated in this box or in this cuboid. Okay. How to find out that? At first I am going to draw the cubes of unit height, length and breadth. Okay. See. Here. This is a unit cube. This is a cube of unit height, length and breadth. This is the height of the unit cube. This is the length of the unit cube and this is the breadth of the unit cube. Okay. This is 1 unit. This is also 1 unit. This is also 1 unit. Okay. So now can you count how many unit cubes are here? For counting that, see here, there are 3 layers of unit cubes. This is 1 layer, this is the other layer, this is the third layer. This is the first, second and third layer. Okay. So see here, this is a layer of unit cubes. This is the second layer, and this is the third layer. Okay. So at first I will count how many unit cubes are there in the top surface. This is 1, 2, 3, 4 and this is 1, 2, 3, 4, 5, 6. So there are 4 into 6, that is 24 unit cubes. 24 unit cubes in the upper surface. Okay, so, or you can say in the upper layer. So there are 3 layers similar like that layer, right, in total. So total there will be 24 into 3, that is 72 unit cubes, right? So I can accommodate maximum 72 unit cubes in this cuboid, right? And that number 72 is the 72 unit cubes, or you can say this is 72 cubic units. That is exactly the volume of this cuboid. Okay. So from where I am getting this number 72? See here, this is the length of the cuboid 4, this is the breadth 6, and this is the height 3 units. If I multiply 4 into 6 into 3, then we will get the number 72. So how I am getting this volume? By multiplying the length, breadth and height of the cuboid, right? I am just multiplying length into breadth into height. This is the volume of the cuboid, formula for the volume of the cuboid. Same thing will be happening here in the case of cube. We know that the length, breadth and height are same in the case of cube. So if I have to count the volume of this cube, here I can see there are also 3 layers of unit cubes, and suppose here each side of the surfaces or each edge is of 3 units, right? So A is equals to 3 units. So here the volume will be A into A cubic units, that is A cube cubic units, right? Here remember the unit of volume will be always in cubic units, right? Why? Because I am here multiplying the length, breadth and height, right? This is for one, this is of 1 unit, this is of another unit, this is of the other unit. So 3 units are multiplying together here, so I am having cubic units. Here also I am multiplying 3 A's together, right? So I am getting A cube cubic units. Now suppose I have just explained by saying there are 3 layers of unit cubes, right? Here see, in other words, this is one A4 sheet, right? If this is the length and this is the breadth, this is the length and this is the breadth of this A4 sheet. So the area of this A4 sheet is length into breadth L into B, right? And if I consider the height of this page, that is very small, suppose I am considering the height as 1 unit, Okay, and I am taking here a bundle of A4 sheets. Here, suppose I have 8 units of A4 sheets. Okay, so what will be the volume of this bundle? That is length into breadth into H unit, that is height of this bundle. So this A4 sheet was here in this box, in this cuboid box. Okay, that was in this cuboid box. Suppose I was asked to find out what is the volume of this cuboid box, then I have to say that L into B into H, where L is the length of this box, B is the breadth of this box, and H is the height of this box. Okay, now for the case of cylinders, suppose this is a cylinder. Here at the lower circular surface at the bottom we have a circular surface, and if R is the radius of the circular surface, so the area is pi r square unit, right? Now suppose I have taken this circular surface, or you can say it is think it as a circular plate. I have taken that plate here. Suppose I am and the height, this area is pi r square, and the height of this plate is 1 unit. Height of one circular plate is 1 unit. Suppose I am taking here 8 circular plates in this way, because the height of the cylinder is h. In this way, how many circular plates can be accommodated in this cylinder? There was 1 unit for one plate, so if there is h, the height is h, then I will have h units of the plates, right? So the capacity will be pi r square into h cubic units. So maximum I can accommodate pi r square into h units of circular plates in this cylinder. That is exactly the formula of volume for the cylinder. Okay.